So example 9, final example of lesson 4.5. Here you are given a problem similar to what we did with our Let the Sun Shine activity. You're given monthly temperatures in Fahrenheit in Albany, New York for 6 months that were on the table. And what we're going to do is we're going to use a trig model or a trig function to model the data. So what we're going to need to do is we're going to let, if January is your first month, we're going to say x is equal to 1. March is the third month, so you would say 3. And then this is going to be x equals 5. July is x equals 7. September, that's the 9th month, and November would be the 11th month for those of you who didn't know. So these are all the odd months. And here are the temperatures for those odd months. So what we're going to have to do is we're going to have to plug these values in for L1 and L2 of our graph, or in our graphing calculator in our stat plot. So go to your stat button and edit. So see if I got to clear something out. I do. So I'm going to go up here and I'm going to hit clear, enter, clears everything out. So I'm going to put in 1, enter, 3, enter, 5, enter, 7, enter 9, enter 11, enter. And I gotta go over here to my L2. Need to clear these bad boys out. So clear, enter. And here I need to plug in a 21, a 34, 58. For the 7th month we have 72. That's not too bad. Nice average. 61 in September, and in November a brisk 40. So I'll put a 40 in here, and we're going to hit zoom 9, and we're going to look at our graph. Here comes the graph, and it looks a little bit like the one we did before. Oh, that's why. Let me get rid of this. That's why it looked exactly like it. So let's hit zoom 9, and we need to turn on our stat plots. That's the problem. So hit turn on plot 1, enter, come down, zoom 9. Here is our graphs. Now this kind of follows and it looks like an upside down cosine maybe, but it could also be part of a sine function. So what we're going to do is we're going to look at our stat button. We're going to go to calculate, and we're going to find an equation for this. And what we're going to look for is either a cosine or a sine regression. I'm pretty sure it only gives us one of them. Yes, the sine reg. So what we're going to have to do is you're going to have to hit C for regression of a sine. Iterations, just type in 1. And go to X list, Y list, period, don't worry about, store, don't worry about, calculate. See if this will do it. Alright, so here is your equation. So we have a 24.7 for A. We have a 0.52 for B. We have a -2 for C. So that's going to be plus or minus 2 here. And we're going to have a 47.3 or 47.37 for your D. So let me see if I can remember all these. So y equals 47.1 plus our A is going to end up being 24.73. I didn't write that right. It's 47.37. A little bit off there. 47.37 plus 24.73 sine of, and then parentheses, we're going to have a B value, which is 0.52, 0.52 x minus, because it's plus and negative, because this is a plus sign here, negative 2.15. So in the context of this problem, let's think about what our graph is. Okay, so our graph is shifted from our normal 0 up 47.37, and what this amplitude means is from this median temperature, you're going to go up an average of 24.73, and you're going to go down an average of 24.73. That's your amplitude. So we need to find the normal temperature in December. All we really need to do is we can graph this equation. So if we go to y equals, and we type in 47.37 plus 24.73 sine of, and in parentheses we have a 0.52x minus 2.15 parentheses, whoops, forgot the 1 here. Insert a 1, and we have our graph. So let's look at our graph here, and the graph fits the data pretty well. If we want to figure out what our average temperature is in December, well, December is going to be our 12th month, so this is where x equals 12. What we can do is we could either plug a 12 into this equation and solve it, or since we plotted this on our graph, on our graphing calculator, we can find where 12 is on our table. So go to your table and look for the 12th month. I don't know if you can just type in 12 here. No, it didn't work. I was hoping it did. And when you plug in a 12, you find out the average temperature is 27.3 degrees. So your temperature, the normal temperature, is frigid, kind of like outside right now. The average temperature is going to be 27.3 degrees Fahrenheit. Now, it says a painting company will accept exterior jobs only when the normal temperature is 64 degrees or higher. So we need to figure out during what months will the company accept exterior jobs. So if we go back here to this graph, what we could do is for your equation, we can just type in on your second y, just type in 64. And that's going to give us a horizontal line at 64. So we only have a few months here in between. So this is one way you could either try to figure out your months here. This looks like it would be above only 3 months here where it would work out. Or you can go back to your table and you can find out, well, which months is it above 64 degrees? There's only 1, 2, 3 months. That'd be the 6th month, 7th month, 8th month, which would be in July or June, July, and August. So this last problem here, example 9, seems to be what you would actually use a trig graph. What you do is you'd have to analyze it and you'd plug it into a like a graphing calculator, and you'd have to use that graph to analyze it. Very few times in your life from here on will you have to actually manually graph a trig function. So hopefully this example showed you a few things that you can do in order to figure out if this is going or where you can actually run into a trig functions. So as I like to say, plot hard, graph hard, and I hope you enjoyed the 4-5 notes.